We already discussed about virtualization and what that entire rabbit hole is about in one of our previous videos. If you haven't seen that one yet, head back to that video and watch that one first, and then we can get started with this one. Now, in the previous video, I talked with you about virtual machines. Now, yeah, virtual machines are still used today, but they are pretty much a thing of the past. The folks who are in the server space, before you come and comment down below that VMs are still relevant, watch the entire video and let me make my point before you go ahead and say that. So instead of VMs, the one thing that everybody is using today is called as containers. What are containers? We'll touch upon that a little later. But first, I want to talk with you a little bit about history, specifically the history of the entire server ecosystem, the entire history of virtual machines, and how containers are coming into the picture here. Now, before going forward, I want you to know that this video is just going to be me talking about the history about servers, how we have evolved, and explaining to you some concepts about containers. In this video, I'm not going to show you any sort of hands-on. Rather, I will make a separate video in which I do some hands-on with containers and show you how you can use those things. So if you want the hands-on section, then do wait for the next video. It will probably be out next week. Alright, talking about history. Now, in the very beginning, before things such as AWS, before Google Cloud, before the entire concept of cloud existed, we had a lot of physical servers. Now, the physical servers basically meant that any single business that wanted to get on the internet, they had to buy their own physical servers, their own hardware. They had to hire engineers to set that whole thing up, to put in a Linux instance, to make sure that the server has a good uptime. And all of that used to become very expensive very soon. And even if you wanted to increase the size of your servers, it became really difficult to do that, because again, you have to buy the physical hardware, you need to wait for it to arrive. Once the hardware is arrived, you need to build up all of the components together. Then you need to configure the server, you need to install a Linux OS or any sort of OS that you're using on the server. You have to put in all of your server management software like Nginx, Postgres, your softwares, whatnot. So to tackle this problem a little bit, we had virtual machines that came into place, or rather this entire idea about virtualization. Within that virtualization, I already talked that virtualization is basically taking a big server and cutting it down into multiple sub-servers. So out of one physical device, you're making multiple usable virtual devices. They're basically doing the same thing as the physical server, but they're completely software defined. So you have them in terms of virtual environments, right? But even with virtual machines, there was a slight problem that virtual machines took up way too many CPU resources. Now, I'll talk about the entire architecture in just a little while, but basically, a virtual machine was an entire computer within itself. So you had this as your physical hardware. On top of that, you get another computer. Now, this one is your virtual machine. This is taking its own RAM, CPU, hard disk resources, whatever. But that also means that there's an overhead on the physical device itself, right? That the physical device needs this additional layer of software called the hypervisor. The hypervisor needs to determine to create an entirely new computer, and so on. Now containers has entered the picture. What's different between containers and a virtual machine? The very core difference is that a container does not create its own entirely new computer. So it doesn't have its own hardware, its own kernel, its own operating system, and so on. Instead, a container uses the same kernel as your host operating system. So for example, this right here is a Linux based kernel. So you have your entire Linux operating system. Let's just assume this is Ubuntu. So you have the Linux kernel, on top of it you have Ubuntu, on top of that you install a container software and you create a container. Now this container is going to use the same host hardware, We already know that with virtualization, right? But the key difference is that the container will use the same kernel which your host operating system is using. So whatever kernel this Ubuntu instance is using, the same kernel will be used by this container that we have created. Make sense? I'm pretty sure you can see how that makes containers a lot more lightweight, right? Since you don't have the overhead about giving the VM its own kernel, its own dedicated hardware resources, it's a lot less system overhead for your processor as well. So TLDR, containers are a lot more lightweight compared to entire virtual machines. Now, like I said, virtual machines have their place in the modern day as well. But if you're talking about a production system, especially one that scales to billions of users, like how Amazon has it, how Google has it, then VMs are really not an option for you, simply because of how much extra resources they eat. Now, if you have just one or two VMs, of course, this extra resources, you're not really going to notice it. But when you scale to thousands, hundreds of thousands of VMs, these tiny resource consumptions quickly add up. So that's where container become a lot more effective, both in terms of performance and costs as well. I did tell you that VMs still have their place, and yeah, that is still true. For example, if you have a developer environment where you're just writing the code of the software and you want to see if that will work or not, so that's where you can still use virtual machines. You put your code onto the virtual machine and let's say it has some sort of a bug. Then you will use the tools which are within the virtual machine to debug them. You can do that on a container as well, but the process is a bit more difficult because containers are meant to be very lightweight. The container will quite literally get rid of everything that is not essential. So you do not even have any sort of debugging tools within containers. If you want a development environment, your preference should be towards virtual machines. But if you're going in production, then you should be preferring to use containers and a container orchestrator. Forget about container orchestrator for now. I just want you to understand about containers. I'll talk a little bit about what containers use under the hood, so the core technologies. Now the tech which containers use is nothing new. It's existed in the Linux kernel for a long time. It's just about how containers are using it. So the two things which they use primarily is called as namespaces and C groups. Let's first talk about C groups. If you have seen my video about Linux process management, you know that an operating system creates certain processes and each one of those processes gets allocated a certain amount of CPU resources, RAM resources, whatever type of resources. Within the kernel, there is a component called as C groups. This C group is who is responsible for allocating these resources, either dynamically, either statically, or whatever. Containers do use the same concept of C groups for managing their resources. Once we go ahead and do some hands-on with containers, you'll notice that unlike virtual machines, where we have to specify how much RAM, how much CPUs, how much storage to allocate to this particular virtual machine, in containers we do not have any of that. So C groups dynamically allocate resources to the containers. They give it as much resources as the container needs. Now obviously there are ways to limit how much resource one particular container is consuming, but by default it will dynamically get that resource. This again ties into how containers are a lot more efficient compared to virtual machines. I told you that containers run on the exact same kernel as your host OS, right? VMs have their own kernels as well. They're entirely own operating systems. So there is that overhead. Now, since containers are using the same operating system, the same kernel, how are they getting isolated? That's where the concept of namespaces comes in. Once again, namespaces is something that's built into the Linux kernel. It has been there for a really long time. Containers simply are leveraging the power of namespaces to create isolated environments. So assume that this is one container, This is another container. These two containers cannot talk to each other unless you configure them to talk to each other. And similarly, these two containers cannot talk to the host operating system either. Now that's all thanks to the power of namespaces. If you have played around with Linux a bit, then you might have come across a command called as chroot. Now chroot pretty much does the exact same thing which we described over here with containers, but the way it is implemented is a little different. Breaking out of a chroot environment is quite simple, and if you just tried to play around a little bit, did a little bit of hacky things, you'd be able to easily get out of chroot. But in the case of containers, they use something else. They use something called as cfroot. Now, I'm not entirely familiar with how cfroot works, but from my understanding, cfroot creates a much better layer of isolation, which is suitable for containers to use. Now, if you want to go ahead and create your own containers, there are a couple of tools which you can use. The most popular one out there is Docker for creating containers. Apart from Docker, there are also a couple of other tools which you can use for creating containers. For example, there is Containerd, which is become pretty much a de facto standard for certain container tasks. I'm not touching much on Containerd in this video. Rather, when I talk about Docker in depth, that's when I'll touch more on Containerd. But for now, just understand that Containerd is become a standard way of creating containers. There are other ways as well. For example, there is LXC, Linux containers. This helps you create containers which are specifically using Linux-based OSs or the Linux kernel. There's also Podman, which is a popular option. There is also a new tool which I came across called as Colima. Now, from my understanding, Colima is like Docker, but more specific for macOS and the entire ARM architectures. So if you want to try it out, feel free to Google up Colima and try it. That's all I wanted to discuss about in this video. I told you about containers, I told you about VMs, I told you about the entire history about containers and VMs, where we used to be. We used to have physical servers, and now we have these lightweight things called as containers. One thing I didn't touch upon is about where containers are used, and in order to understand that, we are first going to have to see some hands-on on containers. So stay tuned for my Docker video which I create. It will most likely be out next week, and within that we'll go more in depth into containers and their entire use cases. If you like this video, please do drop a like and comment about what you liked and what I could change about the way I explain concepts. And yeah, see you all in the next one.